Alright, chapter 6, problem 7 in the book. So, we get a block on the ground pulling the force this way. Alright, so let's do a free body diagram real quick. And technically, the correct free body diagram will have FG, Fn. In this case, Fn is not necessarily, in fact, it's not actually at all equal to Fg. And we have, if the block's being pulled this way, we have friction going opposite that. Force of friction. And F. And this angle is 40 degrees. So that's a free body diagram. That's all we can put on it. Over here, though, we can draw FG, Fn, draw the components, Fx, Fy, 40, Ff. Alright, so the question is, we got this block which has a mass of 3.5 kilograms. Block of mass 3.5 kilograms being pushed along horizontal floor with a force F equals 15 newtons at an angle of 40 degrees. And the coefficient of friction, kinetic friction, meaning it's sliding, is 0.25. It's an equal. What is the frictional force? That's this guy here. And the acceleration. Alright. So, as I was saying as I drew this, is Fn and Fg equal? Normal force and the force of gravity, are they equal in this case? They're actually not going to be, because this force is pushing the block over to the right, but it's also pushing the block down into the floor. And you can hopefully imagine that that's going to increase the normal force. You push the block into the floor is going to push back harder. Newton's third law. So let's look at the F net in the y direction. F net in the y direction. Well, it's going to equal ma. And of course, it doesn't say anything about the block accelerating up or crashing, accelerating into the floor. So it's actually going to be 0. But it's still the sum of all the y forces. And let's call up positive. So Fn is going up, that's positive. Fy is going down, that's negative. And Fg is going down, negative. Alright? So what this means is Fn is actually equal to Fy plus Fg. Let's just bring Fy and Fg over to the other side. Fn, dang, equals Fy plus Fg. So free body diagram, regular diagram, define the direction of motion, net force equation in the y direction. Let's just take this to its natural endpoint. We know the y force because we know the actual force and we know the angle's 40. Y component is opposite 40, so this is just 15 newtons sine 40. Horrible. Just erase that real quick. Come on, 4, you can do it. You can do it. There we go. Sine 40 plus the mass is 3.5 kilograms. So let's go 3.5 kilograms times acceleration due to gravity, 9.8 meters per second squared. So this equals on 15. Oh, what mode are we in? Whew. 15 sine 40 plus 3.5 times 9.8 Fn. What was it? 43.9. Fn equals 43.9 newtons. So that's the normal force. That is not what we're looking for. We're looking for the friction force, which we need the normal force to get that. So that's the friction is in the x direction. So let's set up our net force equation in the x direction. MA. And what's going on here? Coefficient. So we know that let's define direction in the x. Let's define our sign in the x direction. It's positive to the right, negative to the left. So this is going to be in the x direction. There's only two forces going on: Fx and F friction. So I've said Fx is positive minus force of friction. So actually, before I go any farther with this, really, part A is asking for this by itself. So let's just find this first. We have enough information. Part A is asking for FF. Force of friction is mu Fn. In this case, it's sliding, so our mu is mu K. And that's 0.25 times the normal force we found here, 43.9, equals let's just multiply this by 0.25. 10.99. Let's just call it 11. Webassign would accept that. 11 newtons. So that's the force of friction. Part B is looking for the acceleration. That's this right here. And so we can plug in the rest of this stuff into our net force equation in the x direction. We know the mass is 3.5. So 3.5 A, that's from this here, equals Fx. Fx we know is adjacent to the 40 degrees, so that's going to be 15 cosine 40 minus, oh, we just found that, 11 newtons. The force of friction is 11 newtons. So that's simply, we can go 15 cosine 40 minus answer, because this right here, 10.98, is our friction force, and we get 3.505 equals 3.5a. So divide both sides by 3.5, and we get a equals 0.144. 0.144 meters per second squared. Ta-da! Oh, 10 minutes. Jeez. Trying to get these short. Whatevs. Good luck. Bye-bye.